We're here with Glenn Wellbrock of Verizon, and we're getting a 100 gig update. So Glenn, we know that Verizon's deploying 100 gig now in the long haul, but there's talk about it moving into the metro. How soon is that likely to happen?
We're probably going to get the first office application done by the end of the year. We're going to try to anyway, but next year we see his deployment in the metro space, and it's not, it's not as cost effective yet, so it's going to have to be where it's needed the most. But to connect those routers that go in those large locations back to the core network is where we're going to need that 100G first. Okay. So to get between, say, the Lattice core router or the large FiOS facility back onto the core of the network is where those first 100G links will be needed.
How far off is the pricing at this point? Is it?
As good as it looks on the long haul side, that's probably as bad as it looks on the metro. First ones are just not quite there because they got to compete with XFPs.
Sure.
But now you already have this at 40G. It's even harder because you only get a 4x multiplier. At the 100G, you're going to get a 10x multiplier on those XFPs. Now a lot of folks are saying, 2 years from now we should be there. So there is a path towards it. Now we got a workshop this afternoon or maybe tomorrow, and we're going to talk about this. If we leverage the same technology that we're doing in long haul and apply that in metro, can we get the volumes up to save more overall than we might if we used a different solution? So that's the angle that we're taking with the component suppliers, the subsystem suppliers, and talking to them about it. How realistic is that? If we use the exact same technology, can we drive the volumes high enough to get the pricing down?
Right, as opposed to switching technologies and then having a completely different set of economics in the middle.
Yeah, the problem is you look at, could I save 10% by doing different technology, or could I save 20% if I actually leverage the volumes to get them higher? Because volumes are higher in metro, at least you've got more opportunity there. I'm not saying that we're necessarily going to be deploying it day one. It's got to be cost effective.
But there are a need for more systems because there's just more metro locations.
Correct. So there's more metro locations that got to be connected together, and if we can make it cost effective, then I know we can get the volumes really high, and that's what we're talking to those subsystem suppliers about.
Okay. Another topic I want to hit on is the latency improvements on a 100 gig network. How does that benefit Verizon, the carriers, when you're selling services, and where do those improvements come in exactly?
Right, the receivers, the coherent receivers with the digital signal processing allowed us to get rid of the dispersion compensation. Okay. Dispersion compensating fiber goes in at about 15%. So for every 100 kilometers of fiber you have, you had to put in 15 kilometers, which come in a little bucket, a little can. You'd put it in at the amplifier site. The traffic had to go through that 15 kilometers. It's got a smaller physical diameter than the regular fiber, so it has the opposite effect. Okay. And it gets about a 8-to-1 ratio, so 15 kilometers to 100 kilometers, so you don't have to use as much of it. But with 100G coherent receivers, you can eliminate that altogether. So you take that little dispersion compensating fiber that was in at every amplifier before, and you remove it.
Okay, so there's by having to travel less distance, better latency.
Right. It's just a shorter path between two locations, and that's where you save the 15%. There is an additional multiplier or a benefit that comes from the router itself, because you've got a bigger pipe, so your serialization of the data, just how much data you're trying to put down a pipe, has to go through that funnel, if you will. And the bigger the pipe is, you do get an improvement there, although that's measured in single digit.
That's really small.
Really small compared to what we save by just shortening the path, because we don't have to go through dispersion compensating fiber.
Now, how does that pay off in the services end of things? Like when if you're selling a service to an enterprise, are we talking, if we improve by milliseconds, that adds thousands of dollars to the invoice, or?
Yeah,
are you the wrong guy to ask that?
No, I mean, so there's some folks that the financial guys, it makes
a huge difference.
Huge difference to them, but that's a subset of the customer base. And then you got to have the shortest fiber between those two locations that they're interested in than your competition in order to charge that premium, of course, because the shorter the fiber, the lower the latency. There's no, it's 5 microseconds per kilometer no matter how you go about it. So you're not going to do that with equipment alone. It has to be the shortest fiber path. If you happen to have it and you've got the right customer at that end, you can charge a premium. And we've got folks that when we're the best guy in town, that's what we're doing. When we're not, we're trying to say, well, we're more reliable and we can do backup and everything of that nature. So there are some customers that will pay more for lower latency. Everybody gets the benefit. So once you put in this system, New York, Chicago, for instance, every customer gets that added value, but they won't necessarily pay a premium for it.
Okay, that makes sense. So the other big topic, or at least a popular topic, is flexible grid technology, and the discussions we're having here at OFC, is, so we're moving away from the fixed grid spacing to flexible grid that theoretically allows you to put more bandwidth per channel.
Right.
I think I'm saying that right.
Yeah.
More bandwidth per channel. How do you guys feel about the technology? Do you feel like it's ready for deployment? Or?
It's right around the corner. I mean, we're leveraging a lot of the same technology. We've got thousands of boxes already out there. These wavelength selectable switches, either liquid crystal or liquid crystal and silicon, even the MEMS guys can do this.
Okay.
It's not necessarily a brand new function. Or on new hardware anyway. It's new software, it's very complicated software, so I don't want to downplay it, but the hardware itself is relatively stable today. We've used it everywhere. What we're saying is that even if you don't go to 400 or a terabit, what you do is get rid of those fixed filters so you can move those channels closer together. They're coherent receivers, so you don't need a filter at the end anymore.
Okay.
You can use the local oscillator to lock it on and do that final filtering, so now you're information bandwidth limited as opposed to having those fixed filters in there, which means you can get more 100G channels in that same C-band because you've eliminated all the dead spots. You've gotten rid of all those filters, fixed filters, so you eliminated all that bandwidth.
Okay, so and is that something that is going into networks, next year, or does this sort of depend on where the rest of the industry, is with it?
It should be in networks next year. There's nothing to keep it there. Now the full dynamic, boy, we're going to move things around on the fly, and I think that's 3 years from now, 5 years from now. It'll take time to get the control planes built, all the back office systems built to handle this, but simply taking advantage of it for more capacity per fiber is something we can start doing already next year.
Okay, great. We'll leave it there for now. Glenn, thanks very much. Always.